So I just jogged the gripper into a position so we can see it from the bottom, because I want you to notice something about it. This gripper, and this is typical of many grippers, if you notice it's flat on this finger, but this finger has the angled groove. What that means is when we close down on top of that peg, it's not gonna be dead center. It's gonna be further over to this side. So there's probably a way to measure this and be real precise with the geometry of this. There is definitely a way to do it, but I'm going to do it by trial and error. What we're going to do is get the gripper centered back and forth. That'll be easier. We can eyeball that. That's going to be dead center this way. And then we're just going to keep opening and closing the gripper, and at the point where what we want to see is that as it opens and closes, it doesn't disturb the peg at all. It just opens and closes cleanly. Then we'll know that it's in the right position. So what I'm going to do is get it back to the position where it was just in. Actually, that's one point before it, and here's the point after it is moved to the angled position. So first thing I'm going to do is, actually I'm going to come down, I might just reteach this, so I'm going to come down a little closer, knock the speed down a bit more, and I think I'll just re-record that point. I'm also going to eyeball it from over on from your left, so that it comes pretty much dead center. That's good. And I'm going to try to come down. I think I'll leave it where it is. I think it looks good. Okay, so I'm just going to touch up that point. So that's going to be my first, kind of like as I come close to the peg. Now what I'm going to do is come down onto the peg, do some grip and ungrip, and once I find that position, the correct position that I need to be in, I'm going to record it, and then I'm going to back up. And remember, I'm going to use tool coordinate jogging, because that's going to come back straight. So right now, it's critical. I got to back the camera up, hold on. It's critical right now for these next movements for me to shift over to tool jogging. So there it is, it's just one click away from world. So now that I'm in tool, this is going to allow me to come straight down onto the peg. So what I'm going to do is jog in the positive Z direction and bring the speed way down so it's nice and slow. And I can tell already that it's going to be too far over toward the flat side. So what I'm going to do is jog in the negative Y direction, positive Y, so that it's a little off center. Let me eyeball it once again from the right, see if we're nice and centered from this angle, and it looks pretty good. That looks good. Okay, so now this is the test where I'm going to start opening and closing the gripper. So to do that, I'm going to go to the menu. I don't know if you can see this. Maybe not. So I'm too close to the thing. Anyway, menu. I'm going to go to I/O, robot, and we're going to go down to the gripper close. All right, now if I close it, you see how it definitely, I went too far over. So I've got to come further into the groove. So that's positive Y, a little further. So close, open, still moving it a little bit. A little more positive Y. You see how deep into the groove side it has to be. And I think I'm just a little too far. think that might be it. Actually, I just noticed it's moving the thing ever so slightly. There we go. That is clean. I also have to make sure this is good and straight so that when it comes out, it goes back in straight. Okay, so now it's time to go back to my program, and I need to, first of all, I need to record this point. First of all, I need to open the gripper. Let me go back here. Open the gripper back up. Okay, and then back in the program, I'm going to record this point. Now this has got to be a linear move because it's got to come straight down onto that. Okay. Now once it's in this position, I need to enter the command to turn the gripper on. So that's a robot. Okay, great. Okay. So now that it's in this position, I need to enter the command that turns the robot gripper on. So that's IO. It's going to be robot output, and it's output 4, and we're going to turn that on. So let me just execute it using the step. Okay, and now we're going to jog exactly in the negative Z direction to pull it back out of the hole. So negative Z direction. I probably could speed it up a little more, but caution is always good when working with robots. So that's good. That's nice and clear of the hole. I'm going to go ahead and record that position. That's another linear move. It has to be straight as an arrow. Now this is a good time to, let's see, what I can do is I'm going to go ahead and re-record a point and change this to point 3. So what I'm going to do is, just as a test, I'm going to move back and forth between point 4, where it is now, and then point 3 is the point that was in the hole. And let's see how cleanly it replaces the peg and pulls it out again. So we'll go forward. Okay, and backward. All right, that looks pretty clean. Let me pull it around here so you can see it from a different angle. Forward again. And then backward. Okay, so we actually have just accomplished the real crux of this particular program, which is getting the gripper at the right angle using the tool coordinate system for jogging and being able to move straight in and straight out and record those points so that they're exactly on the right angle of whatever we're dealing with. And that is typically what the tool jogging coordinate system is used for, is to produce those kinds of motions that are not relative to the robot's work cell, but relative to the tool and the faceplate. So I'm going to pause it here. So one of the other things about this particular program is that we're actually dealing with two different tool center points. So up to this point in the program, when the gripper has just come down and grabbed the peg, the tool center point has been right up here in between the gripper fingers. Once that peg has been gripped, this is going to become our new tool. So this is a good exercise in writing a program where the tool center point actually changes during the program. So what we're going to do to accomplish that is I'm actually going to stay with the same tool frame. I've already defined the tool frame for this program as tool frame 2. And what I want to do now in the program is to take that, treat it like a tool, change the tool center point to the tip of that. Now up to this point, what I did is I already measured the tool center point from here to between the gripper fingers. It's exactly 82 millimeters. And then the tool center point to the tip of the peg is 167 millimeters. So what we're going to do is take that tool frame 3 and, tool frame 2, and I'm going to show you there's some commands that we can use to change the Z value of that tool frame to a new value. So first thing I'm going to do is, in the program, I want to make sure that the Z value is 82 millimeters when the program starts and when the gripper is the main tool. And then down here, after it grips the peg and pulls it out of the hole, the new tool Z value is going to be implemented at that point. So what I've done in advance is to store the actual coordinates of the tool center point in two position registers. One of them is called gripper and the other one's called grip with peg. So if I hit the position button here and look at gripper, you see that gripper has Z in the 82 millimeters is the Z direction for gripper. And if I go down to grip with peg, it's now changed to 167. So it turns out there's some commands that I can run in a program. And so first thing I'm going to do is insert a line here. So this is right at the beginning. I've just defined the user frame and the tool frame. Now I'm going to make sure that the tool frame has the parameters that I showed you that are now stored in that program, the position register called gripper. So the command for that is I go to instruction, offset frames, and it's down here below the two commands where you define the user frame number. You can take tool frame, hit enter. So it's saying use a tool, and it's tool frame 2, and I can then set it equal to a position register, and it's going to take on the 6 coordinates, X, Y, Z, yaw, pitch, and roll of that coordinate system, and that's going to be number, I think it was 8. Sorry, I got that wrong. It's actually number 7. So 7. That's why it's a good thing that I labeled it, because I can see based on the label that that's the correct tool frame. So when this program starts, it's going to set the Z value of the tool center point to 82 millimeters, which means it's going to match the gripper. Oops, sorry, I was just covering that. It's going to match the gripper.